So we have calculated that with the design we have for the heat exchanger, we have 18 kilowatts of heat transfer rate between the hot fluid, so the fluid that is taken from the workshop, to the fresh air that is taken outside, and this corresponds to the heat recovery we have in our system. So this heat is used to heat up the fresh air from the inlet temperature of -8 degrees outside to this intermediate temperature, a temperature of TS, and then because TS is still lower than the temperature we have inside the workshop, we have an electrical heating that is added to the system in order to increase even more this temperature to the same temperature TA that we have inside the workshop. So we want to calculate this intermediate temperature, and then finally how much heat supply we need to add with the electrical heating. So this is very simple. We just do a heat balance. So the heat balance can be done here on the cold side of this heat exchanger, and the heat transfer rate corresponds to the MCP of the fluid. So here it's the same for any fluid, but we consider the cold fluid, multiplied by this variation of temperature, so TE to TS. And we can calculate that TS is 11.4 degrees. So thanks to heat recovery, it was possible to preheat this air from -8 to 11.4 degrees. Then, in order to calculate this remaining heat transfer rate, we need to add that corresponds exactly to the electrical power of the resistances. We do once again thermal balance between TS and TA. And we do exactly like before. We can calculate we have 7 kilowatts that needs to be added to the electrical heating. This one was quite obvious because in the first question we had calculated that it was necessary to use 25 kilowatts of electrical heating if we did not have any heat recovery. So once we have calculated the heat transfer rate of the heat recovery, the heat transfer rate of electrical heating is just the remaining part. So it's the 25 kilowatts we had calculated in part A minus this 18 kilowatts we had already calculated. So it was in fact quite simple to answer this question, other than doing a heat balance.